Okay, we're going to use the ELS data CSV file in JASP as we work through this example. So let's do an example of an ANCOVA. All right, we wish to explore the relationship between geographic locale, and this is going to be our variable base year urban, where 1 equals urban, 2 equals suburban, and 3 equals rural, and 9th grade math achievement, which is the base year TXM STD. However, we wish to control for the student's math self-efficacy, which is base year math SE. All right, so let's run this in our descriptives first. All right, so our base year here down towards the bottom is base year TXMSTD, which is our variable. And we're going to split by base year urban. All right, and we want our box plots. All right, you'll notice as the box plots are running, we're not really able to look at normality in JASP. We have our groups, urban and suburban, are too large. Rural, we see that normality may be violated, but I'm just going to move forward right now with without evidence of normality. Okay, so looking at our box plots, we see that for urban locales, we have a few here towards the bottom and a few unlabeled towards the top. And then same with suburban and rural, we do have several outliers. But again, let's keep in mind that this data set is extremely large. We've got 15,892 students, so we're really not overly concerned about these outliers. All right, let's run our ANCOVA. All right, so we're going to go to ANOVA, ANCOVA, and our dependent variable is our standardized math achievement and base year. Our fixed factor is base year urban, and our covariate is math self-efficacy. All right, so there it is towards the bottom, base year math self-efficacy. We're going to check descriptive statistics and estimates of effect size, but we want omega squared. We are going to check up both of our assumption checks for homogeneity and QQ plot of residuals. And under marginal means, we want base year urban. Okay. All right, so let's take a look at our output. All right, so we've got our ANCOVA results here. We've got our ANCOVA table, our descriptives table, our assumption checks, our QQ plot, and our marginal means. All right, so let's start with our QQ plot, and we see that this is perfectly well aligned with the diagonal, and so we do have homoscedasticity. All right, let's take a look at Levine's test right above it. And here we see a p-value less than 0.001. That's a problem. That means that homogeneity of variances is violated. So what that means here is that math achievement does not have the same distribution across the 3 locales of urban, suburban, and rural. All right, let's take a look at our interaction terms. So we're going to go under model, and I'm going to select base year urban and math self-efficacy and move that over into the model. And I'm going to scroll up and look at my interaction term. And we see in the table that the interaction term is not significant. It has a p-value of 0.238. So this is telling us that we can assume homogeneity of regression lines. Had this been significant, we would have had a pretty big problem, and we really would have a hard time justifying moving forward with the ANCOVA. All right, now this is important. Before we move forward, let's make sure we remove that interaction term. So I'm going to go back down here to the interaction term and remove it from the model. And you see that everything recalculates, and now in our ANCOVA table, that interaction term is not there. All right, let's take a look at our results. So we've got base year urban, and the p-value is less than 0.001. All right, and so that's telling us that the effect of urbanicity on math achievement is significant when adjusted for the effects of math self-efficacy. All right, so again, this is an omnibus test, and it's saying that between at least two of those locales, the average math achievement is significantly different. All right, and we see the same significant p-value for math self-efficacy. So the covariate math self-efficacy significantly predicts math achievement. All right, and again, let's stay on the slides for a second because, and I'll show you over here in JASP, we've got the descriptives table, but then here at the bottom we have the marginal means. Remember, descriptives, those are unadjusted means. It does not consider math self-efficacy. These adjusted marginal means consider self-efficacy. All right, and so here we can see that, for example, for urban locales of 1, the unadjusted mean is 51.374, but when we take into account math self-efficacy, that mean is a little bit lower at 51.181. All right, let's do our post hoc comparisons now. All right, so let's go into post hoc and add urban. And we want effect size, we want Bonferroni, not Tukey, and we want to flag significant comparisons. All right, and here we see our post hoc tests. All right, and I'm going to switch over here to our slides for a second. And 1, again, is urban, 2 is suburban. And so we see here there's a significant difference between urban and suburban. This negative is telling us that suburban is higher on average, and we've got a significant p-value. So there is a significant difference between urban and suburban, where suburban schools have higher average math achievement. We also see a significant difference between suburban and rural. And again, this is suburban minus rural, so it is positive, again, showing us that suburban schools have higher math achievement on average. And again, our p-value here is 0.003, indicating that it is significant. Okay, now to report the results in APA format. An ANCOVA was run to determine the relationship between geographic locale and 9th grade math achievement, controlling for student math self-efficacy. There was homogeneity of regression slopes as the interaction term was not significant. And again, we report the F statistic, which was 1.434, with the 2 degrees of freedom for urban and the degrees of freedom from the residuals, and that non-significant p-value of 0.238. There was homoscedasticity as assessed by visual inspection of a QQ plot, but homogeneity of variances was violated as assessed by Levine's test of homogeneity of variance. And again, those p-values were less than 0.001. There were a few outliers in the data, but this data set is very large. After adjustment for math self-efficacy, there was a statistically significant difference in 9th grade math achievement between the urbanicity groups, and we can go over here to our table, and we see our 2 degrees of freedom and our 10,000, that should be 439. All right, with our F-test of 14.487 and our p-value of less than 0.001 and our omega squared of 0.002. And again, that 0.002 effect size is a trivial effect, which we note. Post hoc analysis was performed with a Bonferroni adjustment. Students at suburban schools had statistically significantly higher math achievement compared to students in cities, and we report that mean difference. Let's go down here to our post hoc tests. So we report the mean difference between urban and suburban of negative 1.036, the standard error of 0.203, and the p-value of less than 0.001. And suburban was different from students in rural communities, and we report that mean difference and standard error and significant p-value. There was no statistical difference between students at urban schools and rural schools.